Genstat has tools that enable you to analyse individual trials and also combine multiple trials together so that you can perform meta-trial analysis. This video will demonstrate how to do both. This spreadsheet contains 4 winter sown wheat cultivar trials from around New Zealand that test 16 cultivars. Trial A1 has only 13 entries, as 3 of the cultivars are not used in this region. Trials A2 to A4 have entries for all 16 cultivars. There are 4 replicates of each entry in each trial, with all trials arranged in rows and columns. Trial A1 has 13 rows and 4 columns, and Trial A2 has 16 rows and 4 columns. Trials A3 and A4 have 32 rows and 2 columns. The trials are also blocked by columns and groups of rows. Now, some of the sharp-eyed among you may have spotted that Trial A1, which I said has 13 rows, has row values that go up to 14. The reason is that rows 1 and 15 in this trial were buffer plots. Rows 1 and 15 were grown but not weighed to ensure that rows 2 through to 14 weren't exposed to a different environment relative to the other rows, such as extra sun, wind, moisture, nutrients or bird damage. These buffer rows were not added to the data. We'll start our individual trial analysis by importing the first trial. We can find our data set by typing wheattrials.xlsx. The Excel file contains 4 sheets, 1 for each trial. These are prefixed by S. The last entry, prefixed by R, is a named range that's been pre-selected for printing. You can ignore this. After selecting Trial A1, we can click Finish as all the default options are appropriate. We can analyse an individual trial by selecting Stats, Spatial Analysis, Automatic Analysis of Row Column Design. Let's fill out the dialog. Now click Options. We'll select Residual Checks, Best Possible Random Model, and all of the model options. Click OK, then click Run to produce the results. This first section of output summarises all the random and covariance models that have been tried. The model with the lowest SIC has been selected as the best and has been fitted. The output for this model is in the section titled REML Variance Components Analysis. The best model does not use replicates, rows or columns, but does have a linear trend across rows and columns. Let's redisplay the Automatic Spatial Analysis dialog. Click Further Output, then click Residual Plots. Select Shade Plot and leave other settings at their defaults. Now click Run to produce the plot. You can see a large negative residual in row 13, column 4. This negative residual is also flagged in the output. If we want to allow for block effects within replicates, we can select Stats, Spatial Analysis, Automatic Analysis of Incomplete Block Design. This dialog has a specific field for blocks within replicates. We fill out the dialog as shown. Row and column effects can still be fitted in this analysis. To do this, click Options. We'll select Residual Checks, Best Possible Random Model as the strategy, and select all the model options. Now we'll select these two options and set our factors and coordinates. Click OK, then click Run. Using the Incomplete Block Design menu results in a slightly different model being fitted, as the block term is not required. Putting block as an additional term in the Automatic Analysis of Row-Column Design dialog forced the block term into the model, but in the Incomplete Block dialog, it is only fitted if needed. We've finished the single trial analysis, so we'll close our dialogues and spreadsheet and clear the central data pool. To run a combined analysis of all 4 trials, we can read them into a single sheet using Spread, New, Append multiple Excel worksheets. Locate and open the wheat trial spreadsheet. Select all 4 sheets, then click OK. This produces a spreadsheet containing all 4 trials. The column worksheet gives the name of the sheet the data came from. We can rename this to Trial. Now we can analyse the combined data using Stats, Meta-Analysis, Automatic Meta-Analysis of Trials. We'll fill this in as follows. Now set the options. We click OK, then Run. Now let's examine the output. Here we see how the optimal model is fitted to each trial. This table shows how the estimates are combined across trials. Selecting residual checks in the Options dialog produces this large residuals heading in the output. This suggests the value in row 7 of the spreadsheet for yield is an outlier that should be checked. We'll redisplay the spreadsheet and bookmark the final cell in row 7 using the shortcut keys Alt+A. Now use this Restrict Spreadsheet button to restrict the cultivar column to show only the variety excess. We can see that this yield is lower than usual for excess. This tutorial has demonstrated how Genstat can automatically determine appropriate random or correlation models. Bear in mind though that no automatic method can guarantee to work as well as a detailed investigation by an expert.